Great. Let's do a quick review. In the previous lesson, we learned the math operators. They are pretty straightforward and easy to understand. And then we learned Java method overloading. The overloading means you can have multiple methods of the same name, or even same return types, and different set of parameters. You cannot have exactly same parameters. You need at least one is different. So in this case, you can have int, and you cannot have int again. You can have int and then double. At least one parameter is different. Otherwise, they are treated as duplicated methods. As overloading, and today we are going to learn more the second group of operators. It's called assignment. You basically assign a value to a variable. For example, assign integer 5 to variable x. That's an assignment. It's a single equal sign. And then what if you want to add a value to a variable and then assign the result back to that variable? You can do that, right? You can do that. That's no problem. But then there's a different way to express that. Since the variable is on both sides, you can just keep the left side and then drop the right side. But you have to shift the plus sign in front of the assignment sign. So it's plus equal. So it's called additional assignment. Okay. And similarly, for subtraction, x minus 3, and assign that value back to x, then you can also drop the x on the right side and shift the minus sign in front of the equal sign. So that's a different way to do it. And this expression is called subtraction assignment. And the multiplication and division and even modulus. Okay. And we can try the examples. There are a bunch of them. Let's just copy in here to, I think I need a new file. New file. Oh, two new. It's a difference. Okay, main.java. Okay, hope that's okay. Oops. That is better. So put that in. Okay, that's good. And save that. I think we want to keep a main, right? And save that as. I don't just put on top desktop. Call it main.java. And back here, desktop. Have the Mega Java. Yep. So let's compile it. Oh, what's the point to compile? We haven't done anything yet. Just get it ready. This is so we want to add. Well, let's say assign value, initial value to 5, and x plus equal to 3, and then we print that out. Let's see, print that out. So initially 5, add 3, then this line should print out 8. Okay, oh, I see. Yeah, if we just add another print here, that's 5, and then that's 8. And let's verify that.
Your screen is really blurry.
Oh, really? My screen is blurry. Yeah. Why is that? How about others? Oh, chat is blurry. Okay. Okay, all blurry. Let me shift the screen to the right side. Let me stop the sharing. Okay. And let me shift everything to the right side. Let's see if that helps. Give me a minute. And then I need to hide the status bar. But automatic hide. Okay. Let me share one more time. Excuse me. Where's the makeup? Let me share again.
Now it's even blurrier.
Worse?
Oh, now it's better.
Now it's better, right? Okay, let me see. Okay. Okay, good. Sorry, I didn't pay attention to the chat window. Okay, we are here. Let me check the window there. Move that to this side. Not to record. It's here. Okay, good. Okay, just yeah, just speak when something happened. All right, good. Let's continue. So I hope the recording is okay. Yeah, I think so. Let's compile this program and let's run it. We should print out 5 and then 8. Oh, what happened? Oh, I did not save. So 5 and 8. Okay. Why do we need this assignment, the assignment operator. Like, yeah, well, this one, this way it works and easier to understand. Like the math we normally see in math classes. So that works. You see this only in computer programming language, right? It's because it's a way to save typing or make the code cleaner, not wordy. So for example, you can say, X is a very short variable, but you can say, hey, this is a very long variable. You can have something like that, and that's the case actually in the real computer application. Programs do pick a variable name very long, almost like a short sentence. That's because they want to make a variable that is meaningful. By just reading the variable, you understand what the variable is about, right? So they can just pick a name just like that. This is whatever variable. This is for whatever purpose. So make the code meaningful, but then that make the variable very long and big. So if you use this variable, yeah, you can really long. You can add type more. But if you use a long variable, then if you do the math like that, you would have a line that long, right? So yeah, just that long. So in this case, if you use this assignment variable, then you can drop that one. You can drop that one and move the thing in front. So now this line is shorter, still long, but at least you don't have to repeat that variable on the right side. So that's why we got this they combined the assignment variable and the what do you call that? The right here, the arithmetic operators. So this combine 2 to 1. So make the line shorter. I think that's the only purpose, no other purpose. And of course, we'll have a long variable, then we cannot use X anymore. That make the other line longer. That's fine, because since if you decide pick a long variable, then yeah, you have to use that. So let's see, we compile it. And of course, it works. Nothing wrong with a long variable. But when you pick a long variable, you see the convention, start with lowercase, and then for each beginning letter of a word, you use the uppercase. Okay, that's a convention. You should not use all lowercase or all uppercase, because if you do that, it's hard to read. It's really hard to read the variable. So with this uppercase on every first word, then it's a lot easier to read. Yeah. So that's the way to pick a variable. Back to the assignment variable operators. We try the plus. Of course, we can try minus. It's just same, same thing. Minus. We should get a 2 back, something like that. Time. Yeah. And the time, yes. Time, that means if you want to time the variable by a value and assign back, So then we should get 315 back. Okay. Of course, every time you change it, even a single character, you have to compile the code. There we go. And divide. Well, 5 divided by 3 probably should be 0.5, right? But probably we won't get. .5 back. Did I save in the compile? No, I didn't save. Recompile. Rerun. Yeah. Oh no, it's not. Yeah. Yeah, 5 divided by 3 should be. What's that? I think. Something like that, right? But of course we don't get that because it's integer divided by integer. Oh, and assign back to integer. So that's why. So if you want to do the double, then really you should do that thing. Yeah. But will that work? Save. Think in your head and guess what we will get. Oh, okay, so that worked. Oh yeah, the F. Remember, if you assign a value to a double variable, then by default, yeah, it's a double a value. You don't have to type a D. You can. So that's okay. Yeah. So let's see. Next one. Got division. Oh, the module. Modulus. There's normally for integer, I think. 5 modulus is what? It should be 2, right? Yeah, 5 divided 3 is 1, 3, and then remainder is 2. So we should have that. Well, yep, that's 2. All right, enough with that. This is very straightforward, not complicated at all. Next operator is called a comparison operator. Basically, you compare 2 values. If you use equal, it means equal to they're equal to each other. Well, that's not equal to, or greater than, less than, or greater than, or equal is or equal, less than or equal. And the result, of course, is true or false. Just print out the true or false probably is not that useful, but it's mostly in the later when we learn the logic is used to test, to do the test or condition, if x equal to y, you do blah blah this thing, and if not equal, then do something else. If greater than, for example, if let's say x is age, if age is greater than 10, then you print out, okay, he's 10 years old. If less than 3, you print out, oh, he's less, younger than 3, something like that. Not necessarily just print out true or false, but it's in the test, like if, else, something like that. But for now, to learn the operator, we just want to print the value true or false out. let's see. Yeah, comparisons. Yeah, they said is compile the two variables, assign a value in a comparable, or you can compare a variable with a specific value. So this is same thing, just a little bit different. That should be main. I'll fix that. So back to the here. Let's make a small again, short again, since we don't really care about the meaning of the variable for now. So let's see, X, I need another Y. Well, you can do that. You don't have to do the separate line, even though the practice is you will have separate lines, but you can do that, that's no problem. That. Let's say X equal to Y, true or false. So of course this is false. Save it, compile. It's false, of course. 5 not equal to Y, so that's why it's false. And say, okay, are they not equal to each other? True, they're not equal to each other. Is X greater than Y? That's true. That's true. Because to verify, just run the program. It's true. Yeah, less than. That's false. It's greater than equal. It's greater than or equal. In this case, they're not equal, but they're greater than. But since this is all, then the result is true, because true or false, then the factor is true. If true and false, then the final result is false. So compile. So that's true. Yep. That's greater than. Less than, of course, not equal, not less than, then the false or false result is still false. So then if we do that now, run the program now, it should be false. Yeah, so it's a false. Okay. Yeah. And put that into some, I think we haven't learned the logic yet, right? Yeah, we'll learn that, how to use the true or false. But we can try that for now. Let's say try one more thing. If X is smaller than Y, right? Then I print out something like X is smaller than Y. Right, else if that else of course not small, cannot say greater than, because whatever if they are equal. So if X is less than but smaller than Y, okay, yeah, X Y, else X is not smaller than Y. So this is how you use this this comparison. So pretty much is used as a condition or called a test. Test the comparison. Let's save that. compile. Yeah, so because 5 is not smaller than 3, that's why say, yeah, 5 is not smaller than 3. Of course, if you change it, then that's different. Yeah, x is smaller than y, and then 2 is smaller than 3. So it made the first test of the conditions will print it out. So else print that. So that's how normally you use the comparison. Okay, let's see. We have some minutes left. Not equal to. Good. The next thing I want to show you is called Java scope. What is Java scope? Remember the variables we declare here? The x, y, you declare here or define here, then the x, y can only be accessed within this method. So this is called a scope. Just so the visibility of any variables you declare is limited to that block of code or region of code. So if you define the x, y inside this main method, then the x, y can only be accessed inside main and also after they are declared. You cannot, if you print x, yeah, x2, you cannot access the x value or the variable x before it's declared. So this place is, even though it's inside the method, but it's because the variable is not defined or declared yet, so you cannot print x before, before this line. So the scope starts from this line, when the variable is declared, and then after that, to the end of the method. You cannot, like, if you do that here, then that's not allowed. Now, of course, get an error because you cannot print that outside any function. But even though you put a specific function, let's say static by method one, it's my method. Yeah, static. Yeah, now there's no syntax error, right? There's no syntax error. But if this won't print anything. Let's say x equal to what? This also x equal to what? Let's save the thing. Save it. Screen. Compile. Compile. Oops. Say it get an error. The first error is line 3. Line 3 here. Cannot find symbol. So that means, hey, you print something, but it's not defined here. So that's the error. You cannot even pass the compilation. I'll comment on that. And then compile one more time. Line 13. Line 13. Same thing. Cannot find symbol. Yeah, when you the compiler doesn't say, the variable, or they always call a symbol. And here they symbol as a variable. I guess there's something else is also, called like a symbol, like a keyword or something, not necessarily a variable. The variable is one kind of symbol, but symbol is not always a variable. That's why the compiler say I cannot find symbol. And after that, I guess use this context to determine, you probably mean it's a variable, but still can't find it. So that's an error. That's compile error. So that indicates that you cannot access the X variable defined inside another method, because here is two methods. There's one method and there's a second method. So that's also error. Of course, you say, oh, okay, that's my parameter. Then that's fine. That's totally fine. It will compile. No problem. Yeah, that's no problem. But still doesn't mean this X is that X. This X is a local X. It's X you redefine here. So this is a different X. Okay, it's different variable. All right. So that's a scope. Let's see. Oh, yeah, it's pretty much the same thing. Yeah. So the X defined main method is not accessed from here, and not from here, and it's okay. So it's okay from here. If we run the program, yeah, X is smaller than Y, so that's okay. So X is that's okay. That's the okay part. This is not. That's not. So that, and this part called a scope. This is called the scope, and specifically called a method scope. This is called a method scope, and there's another scope called a block scope. Let's see. A block of code refers to all of the code between curly braces. Variables declared inside blocks or inside that block of code are only accessible by the code between the curly braces, which follow the line which the variable declared. Example here. So curly braces, that's a block. And if you declare the X, then you can access X here, but not outside the curly braces, not before, not even after, even though they are in the same method. So what that means is, so forget about this method thingy. If we add extra curly braces, yeah, here. Here, then that's a block of code. This is called a block of code, this block. Then you cannot access X before this block, or even inside the block, of course, even the inside block, because before it's declared, you cannot. That's not okay. I don't think that's okay, not okay. Also, if you use outside the block, that's also not okay. Even though it's inside the same method, but since the variable is defined inside this curly braces here, this block, then outside the block, you cannot access it. Let's save in a compile and see what it says. Of course, bunch of errors. Let's see. Line 6. Cannot find simple. Line 6. Yeah, see, this line is inside the same block. They still say I cannot find X. That's because the X is not declared yet. So that's not okay coming up. And then another one, line 16, cannot find simple. 16, yeah, right. So this is outside the block where the variable is declared. That's not okay. That'll delete the line. Then we save it. And compile. Yeah, no problem. And of course, if we run it, we get the result. Just that line. To be honest, use curly braces to block a line. I haven't used that. And I don't think it's that popular. Normally, you see the curly braces after a method, start a method and end the method, or the I know. Yeah, the other places is something like this, I think. Variable A equal to 1. How about that? And let me say if A equal to 1, you do that. And then here, else if A equal to 2, you do another block. Something like, I don't know. Yeah, right. Right. Yeah. So this is a block of code. That's another block code. Yes. Yeah. If this, yeah, in the if else logic, then this is popular. So earlier I said it's not common is if you just, for no reason, you just block multiple lines into a block, and then it's kind of weird, right? It's weird. But if you are doing the test or do the comparison and do the conditional execution of the code, yes, then you do need the open close. If it's a single line, if just after the condition, you just one line, like the example we just tried earlier, then you do not need to use curly braces to group the line. But if you have more than one line, you do need the curly braces to group them into blocks. Yes, in this case, yes, it's not, not only popular, but also actually required. So let's save this code. Compile. Where's my compile? Yeah, let's get error line 20 because we try to print X and the X is defined inside here. That's, yeah, this is another example of block scope. So this is a different block. you cannot print the variable defined in this block. So if you do need to share a variable, you can, well, how about take this out? No, you have to move that out. Move that out. Then, right, see, if you define here, then all the blocks can access this variable because all the blocks underneath, they are all inside the same method, then that's no problem. If I save that code and then compile, yeah, there's no complaint now, right? So what if we run the code? A to the run the first one because A is 1. Yeah, that's true. If A is 2, that we should run this part, and this part will print the X out. That's printed 2. So make it bigger. We don't want to use 2, 3. It's so similar. Compile, run. Yeah, so that print 20. That's from this line. And also I want to show you that for single line, like this block, you don't need the curly braces. But you cannot leave the space line. If you leave the space, then let's see what happens. Oh, actually, it's okay. Interesting. No, that's not okay. I don't think. Let's try that. Add a number to it. Okay, let's save it. What time now? Oh, almost. Give me 3 more minutes since we started a few minutes late. Compile, run. See this thing? If we don't use curly braces, if this condition is met, it will run all the lines after that. So if say, I only want to print X, not X plus 10, then you should leave no space or add the curly braces. So you do that or do this and no black line. And that's okay. So basically, if that only one line is get executed, not this one, but this one is, well, yeah, it'll get executed, but it's not because it's else if. I'll show you what I mean. Compile. Of course, you get a 2030 out. 2030. Got this line get executed because this condition. These lines get executed because no matter what, it's get executed. Not necessarily because this condition. Because this line is outside this if, else if thing. So if we change A to 1, it still get a print out. Yeah, so in this case, A1 got this block and then skip this else and then print that out. So what I'm saying is that if you don't use the curly braces, then for that condition, only one line, get executed for that condition. So, and this line is just outside. But anyway, hope that's not too confusing, but that's why to be on the safe side, you always use that. Then that's less confusing. Okay. Let's see, where are we? I think we are all here, and the time is okay. Good. Do you have any questions? If no questions, then we stop here. I should stop sharing. And I see you next week.
Bye.
Bye-bye, everyone.
Bye. Thank you so much.
You're welcome.